Hi everyone, I'm Lakshmi, Department of Mathematics, SNS College of Technology. Already we discussed some more sums in based on Fourier series, the limit 0 to 2 pi and 0 to 2l. Now today I'm going to substitute instead of 2l, I'm going to replace some values and how to do the sums. We are going to see now. So I'm choosing that function f of x equal to um, f of x equal to 2x minus x square with the limit 0 to 2, 3. So the given interval is 3. So it becomes based on that 0 to 2l. So that is instead of 2l we are having the value as 3. So that from this l equal to 3 by 2 we got. So instead of l wherever it comes we want to replace by 3 by 2. So I'm writing that formula. Fourier series formula, that is f of x equal to a naught by 2 plus summation n equal to infinity a n cos n pi x divided by l plus summation n equal to 1 to infinity b n sin n pi x divided by l, and then we can replace for the l value, that is 3 by 2, that is we can write it as it becomes 2 by 3 when write it as a reciprocal term. So here also it becomes 2 by 3. So after this we got the general formula, and then after this we can calculate one by one that a naught value with the limit 0 to 2l. So instead of this l replace 3 by 2, that is it becomes, it is in the denominator, so it becomes 2 by 3 in here, and the limit is 0 to 2l. So instead of 2l write 3. So 0 to 3 we can write, and then write the function, given function 2x minus x square, and then we can proceed the sum. So the integrating that it is clearly we are having, that is integrating the first function and minus second function. Now, so first function 2 is a constant, integrating x is x squared by 2, and then minus x square divided by 3 we got. So applying the upper limit minus lower limit, we got the conclusion like this, that is 9 minus 9 it becomes 0. So that a naught value we got it as 0. Next we can proceed this calculating the an value. So first as it is we are writing the all those values. We know f of x into 1 by L. So 1 by L, write it as reciprocal term 2 by 3, and then apply the limit 0 to 3 and f of x cos n pi x divided by L. So instead of L we are replacing the 3 by 2. So we got that, we can write it as 2 by 3, and if write the f of x value. So again product of two functions, we are proceeding the Bernoulli rule. First write the u value and then integrating cos is sine. So here the constant is 2n pi divided by 3. This is a one time rewrite, and then with the alternative sign minus, and then differentiate the first bracket and integrate the second bracket. It's a basic concept, it just keep it in your mind. So with the alternative sign plus differentiate the first term and integrate the second term. This is enough to recall the Bernoulli rule. So the first integration is, first differentiation is 2x minus x, u when you are writing u, and first in differentiation is 2x is 2 minus x squared is 2x. After that minus 2 minus 2x instead, and then we got that minus 2, and then integrating sine is minus cos, and minus cos is integrating minus cos is minus sine. This is, and in first integration one time, second integration two times, third integration three times. That's all. So easily we can recall all those values with the limit, and with the limit 0 to 3. So in this limit we get only in cos terms. So that write the cos terms alone and apply the limit, and you'll get the answers here. So the answer is an equal to minus 9 divided by pi n square pi square. And same thing we can calculate the bn value. So instead of this integration only, you get the difference. So again in Bernoulli 2 minus x square 2x minus x square in the sine terms we got. So in first integrating sine is cos, and then this integrating sine is cos, and then integrating cos is minus sine, and then again minus sine integrating that minus sine cos. So these terms only will change in comparing to the an and bn, otherwise the same values only we will write. So after this the sine term becomes 0. So we got two cos terms alone. That two cos terms alone you just in the two cost terms alone, write the upper limit and then lower limit, upper limit minus lower limit, and here we are replacing those values, upper limit value and then lower limit value. When you are applying the limit values, and cos 2n pi value is 1 and cos 0 value also 1. So each and every value be getting the positive term. So after this we got only the constants from these value. So the conclusion of this term is 3 pi n pi. So we got an, bn, cn, a naught, an, bn. So applying write all the values here in this equation, we got the solution for this function f of x. So this, thank you.